welcome to the deep dive. We're taking some pretty complex source materials today, things aimed at advanced security architects.
Yeah, the real technical stuff.
And we're going to break it down, turn it into a masterclass, really, on blending Fortinet security with AWS and Azure.
Our goal today is basically to give you a shortcut. Get you thinking like an architect dealing with FortiOS 7.6, FortiWeb 7.4 in the cloud.
Right. We want to look at how you actually build for high availability, for consistency across clouds, for compliance.
And critically, how those Fortinet tools talk to the native cloud services. That's the key interaction.
Exactly. It's not just about the firewall features. It's about that handshake, understanding where Fortinet stops and, say, AWS takes over.
Designing that whole resilient system.
Okay, let's unpack this. First, big topic, high availability, HA, keeping things running.
Right. So think about your standard active-intensive FortiGate setup in AWS.
Okay.
The big challenge, the real headache, is always the failover. What happens when that active FortiGate VM just dies?
The passive one needs to take over immediately.
Instantly. And it needs to grab the resources that define its public connection. Usually that's a floating elastic IP, an EIP, or maybe it needs to change the VPC routing rules.
And here's the architectural puzzle, right?
Yeah.
How does a virtual machine, which is basically just software running on AWS hardware.
Yeah, it's a guest.
How does it suddenly get the power to reconfigure AWS infrastructure? Like, detach an EIP from one network interface and stick it on another. It's not like it has admin rights to the whole AWS environment.
It doesn't, and that's the absolute first principle you have to grasp in cloud security architecture. The firewall cannot act alone.
Okay.
Any action like that, modifying AWS resources, it has to be explicitly allowed using AWS's own identity system.
You mean IAM, Identity and Access Management?
Exactly. The FortiGate instance must be assigned an IAM role.
Ah, okay. So the IAM role is like its temporary security badge.
That's a great way to put it. It gives that specific instance the exact AWS API permissions it needs for that failover task.
Like permission to call the detach address and attach address API actions, or maybe replace route?
Precisely. There's usually a script running inside the FortiGate during failover, but that script only works because it can authenticate to the AWS API using the credentials provided by that IAM role.
So no IAM role.
No automatic, seamless failover. The passive FortiGate just sits there, unable to take control of the EIP or routes. It's fundamental.
That makes a lot of sense for HA, dealing with state changes. But let's shift gears. What about visibility, especially in Azure, where things can be really dynamic?
Oh yeah, dynamic environments are a whole different challenge.
So say we have security policies based on tags. We want to apply rules to anything tagged web server. But those VMs might scale up, scale down, change IPs constantly.
Yeah.
How do we keep the policy accurate?
Well, you definitely can't rely on static IP addresses in your policy.
No way.
The moment a VM gets replaced, your policy is broken if it's tied to the old IP. That's a huge issue in cloud-native designs.
So we need something constantly watching Azure, looking for those tags, and telling the FortiGate, hey, these are the current IPs for web server.
We do. And while the FortiGate could theoretically try to query the Azure API directly,
It sounds inefficient.
it is, and it's not really its core job. That's why we use an abstraction. The tool here is the Security Fabric Connector, or the SDN connector as it's often called.
Okay, the SDN connector, what does it do?
Think of it as a dedicated communication bridge. It maintains an ongoing connection to the Azure Resource Manager API.
Right.
It continuously asks Azure which VMs currently have the tag web server. And then, crucially, it automatically updates the dynamic address objects inside the FortiGate configuration with the latest list of IP addresses.
Ah, so the FortiGate policy just refers to the dynamic address object, not the individual IPs.
Exactly. The SDN connector handles the translation. It turns cloud metadata, the tags, into something the firewall policy can actually use, the address objects.
And that keeps the security rules relevant, even if the underlying VMs are constantly changing.
That's the goal. Accurate policy, automated updates.
Okay, so we've got resilience with IAM roles, visibility with SDN connectors. That kind of leads us to the start of the process. Deployment, infrastructure as code, IAC.
Yeah. Super important for architects. Consistency is key.
Right. So if we need to deploy something fairly complex, like a whole FortiGate auto-scaling group in AWS, the ASG itself, the subnets, security groups, load balancers, the works,
The whole stack.
and we want to use the native AWS tool, for defining and deploying all that automatically?
Then you're looking at AWS CloudFormation.
CloudFormation.
It's the AWS service designed for this. You define everything. The FortiGate ASG configuration, the network resources, dependencies, all in a JSON or YAML template file.
And CloudFormation handles creating it all in the right order.
Yes, it manages the dependencies and the lifecycle. It's really powerful for keeping your AWS infrastructure defined as code.
Okay, CloudFormation is great if you live purely in the AWS world. But let's be real, many organizations are multi-cloud now.
Very common, yeah.
So if the requirement is deploy a consistent security baseline using FortiGate across both AWS and Azure, CloudFormation won't cut it, will it? It's AWS specific.
No, it's fundamentally tied to AWS resources. For that multi-cloud consistency, you need what you call the multi-cloud glue.
And that is?
Terraform.
Terraform. Why Terraform?
Because Terraform is designed to be cloud agnostic. It uses its own configuration language, HCL, HashiCorp configuration language.
HCL.
And you can use HCL to define resources for AWS, Azure, Google Cloud, Fortinet itself, many other providers, all within the same set of configuration files.
So what's the big architectural advantage it gives you over, say, using CloudFormation for AWS and Azure Resource Manager templates for Azure separately?
It's really about the state management. Terraform keeps track of the infrastructure it manages in a state file.
Okay, a state file.
This file maps your HCL definitions to the actual resources running out there in AWS and Azure. It knows what it created.
And why is that so important?
It prevents configuration drift. It ensures that what's defined in your code is actually what's running, and it helps manage changes and dependencies across both clouds from a single control point. It enforces that baseline consistency.
Got it. So ASE tools like CloudFormation or Terraform build the infrastructure, set up the FortiGate VM.
They build the walls, yeah.
But what about configuring things inside the OS after it's launched? Say you need to install a specific monitoring agent on an EC2 instance protected by the FortiGate, or maybe run some initial setup commands on the FortiGate VM itself after it boots up. This isn't infrastructure provisioning anymore. It's more like configuration management.
Exactly. You're moving from building the environment to configuring what's running inside it. And for those kinds of tasks, post-deployment configuration, running scripts, installing packages, ensuring state within the OS, that's typically where you'd use Ansible.
Ansible, okay.
Ansible excels at connecting to running instances via SSH usually, and executing tasks defined in playbooks. It's great for those ad hoc jobs or ensuring the final configuration details are applied after the main infrastructure is built by Terraform or CloudFormation.
So it's a life cycle. Build the infrastructure with IAC, then configure the internals with something like Ansible.
That's a very common pattern. Build the walls, then paint the rooms.
I like that analogy. Okay, let's pivot now to maybe the most painful part of the job, troubleshooting, when things break.
Ah, yes, the fun part. Troubleshooting in the cloud adds layers of complexity. You can't just assume it's your firewall.
Tell me about it. You're staring at the FortiGate logs, you know the policy allows the traffic, but it's just not working.
Been there many times.
Let's take Azure first. If you're trying to figure out network latency, or you just need to see the raw traffic within an Azure virtual network before it even gets near the FortiGate's virtual network card, what's the native Azure tool you reach for?
For that kind of deep network diagnosis inside Azure, your first stop has to be Azure Network Watcher.
Network Watcher.
Absolutely. It gives you the tools for native packet capture within the VNet. It provides network flow logs, connection monitoring tools. It lets you see if and where traffic is getting dropped or delayed within the Azure Fabric itself, completely independent of your FortiGate. It's your primary diagnostic layer for the Azure network.
Okay, critical first step. Now the classic scenario. A virtual machine in Azure is unreachable. You've double-checked the FortiGate, the policy looks perfect, traffic should be allowed.
Yep.
This happens all the time, drives architects nuts. What's usually the native Azure thing that acts like another checkpoint and might be blocking the traffic, even if the FortiGate says yes.
This really hammers home the defense in-depth concept in the cloud. The most common culprit here, network security groups, NSGs.
The NSG. Often forgotten, but always there.
Exactly. NSGs apply filtering rules directly at the network interface of the VM or at the subnet level. So even if your FortiGate has a rule allowing, say, inbound SSH, if the NSG attached to that VM's NIC or its subnet has a rule denying inbound SSH, the NSG rule wins.
Because it processes the traffic before it even gets routed to the FortiGate for inspection.
Precisely. The packet hits the NIC, the NSG checks its rules, and if it denies it, The packet is dropped right there. It never even makes it to the FortiGate. So the architect must ensure the NSG allows the traffic to reach the security appliance first.
And a great reminder, deploying a fancy firewall doesn't make the cloud provider's built-in controls just vanish. You have to account for both.
You absolutely do.
Okay, let's switch that scenario to AWS. Similar problem. A connection is failing, maybe across a VPC peering link. Again, if you check the FortiGate policy, it's definitely correct. Before you even think about security groups or anything else, what's the fundamental AWS networking component you must verify first?
You have to check the path, the network path. In AWS, that means checking the VPC route tables.
The route tables.
Yes. The route tables associated with the subnets on both the sending side and the receiving side of that peering connection. If those route tables don't have an explicit route entry pointing the traffic for the destination VPC across the peering connection,
The packets don't know where to go.
exactly, they'll either get dropped or sent to the default route, maybe the internet gateway, but they certainly won't reach the intended destination across the peer link, regardless of what any firewall policy says.
So the key architectural point is, route tables define the path. Firewalls enforce policy on that path.
Couldn't have said it better myself. If the path isn't configured correctly, the security policy is irrelevant because the traffic never arrives for inspection. Routing first, then policy.
Okay, that makes sense. Let's move to our final section, compliance and using more specialized security tools.
Right, important stuff.
We've got potentially lots of Fortinet devices deployed, FortiGates, maybe FortiWebs for application security, maybe even FortiCNP looking at cloud posture. That's generating a ton of log data.
Massive amounts. Security events, traffic logs, audit trails, configuration changes.
For compliance reasons, audits, reporting, incident response, we need to collect all of that, centralize it, store it long-term, and analyze it. What's the designated Fortinet product for that job?
For centralized logging, analytics, and compliance reporting across the Fortinet security fabric, the answer is FortiAnalyzer.
FortiAnalyzer.
It's purpose-built for exactly that. It ingests logs from FortiGates, FortiWebs, FortiMail, FortiCNP, you name it. It normalizes the data, provides long-term storage, runs reports, performs security analysis. It's the central nervous system for security visibility and compliance data.
The single source of truth for the audit trail.
That's the idea.
Okay, one last specific tool. Let's talk web application security. Imagine we have microservices running on, say, AWS EKS Kubernetes.
Okay, common scenario.
We need really deep inspection of the HTTP and HTTPS traffic coming into and maybe even going out of those microservices. We need protection against things like SQL injection, cross-site scripting, OWASP, POP10 stuff. A standard network firewall isn't really designed for that deep application layer inspection, is it?
Generally, no. A traditional firewall is great for network segmentation, controlling ports and protocols, maybe some basic intrusion prevention, but deep web application security requires a specialized tool.
And the Fortinet solution for that specific web application firewall, or WEF, capability.
That's FortiWeb, specifically FortiWeb VM for cloud deployments.
FortiWeb VM.
It's the dedicated WEF. It sits in front of your web applications, like those EKS services, and inspects all the incoming HTTPS requests and outgoing responses, looking for malicious patterns, enforcing security policies specific to web apps. It understands web protocols deeply. That's the standard architectural pattern for protecting web applications.
We really encourage you, the listener, to dig into those specific connections we talked about. IAM, SDN connectors, route tables, NSGs in your own cloud environments.
Definitely worth exploring.
Thank you for joining us for the deep dive.